Hello everyone, welcome to Reactify Labs. Today I'm going to talk about a very popular theorem of system design called CAP theorem. Ah, sorry. Hmm, CAP theorem. Okay. So what does CAP theorem stand for first of all? So this is CAP. CAP stands for actually like this. CAP stands for consistency, availability and partition tolerance. I think we all understand what consistency, availability, and partition tolerance mean, but I'll still explain. So, consistency means all nodes in a distributed system have the same data at the same time. Okay. And as we know that one database cannot hold all the information, right? So, if we have multiple databases, for example, systems like Facebook, Google, they have multiple databases. So if you check your Facebook account from India or from US or from anywhere in the world, you will get the same data, right? So this is called consistency. Actually, Facebook is not the right example to give for consistency, but actually that works here also. The best example would be your bank account. You check your bank account from anywhere in the world, you will always get the same amount that is there in your bank, right? So because they ensure consistency. And this database, as I mentioned here, we have multiple databases. Your data is distributed across different databases. Your phone connects to different servers, and which in turn connects to different databases from different parts of the world. So all those are called nodes, and your all nodes are consistent. All nodes have the same data, means they are all consistent. So consistency means all nodes in the distributed system have same data, okay. Next comes availability. Availability means whatever the request is, it should get a response. So it means, first let me write it down. Every request receives a response, even if some nodes fail, thus ensuring continuous service. It means whatever happens, no matter what happens, your request should give a response. It is possible that if there are multiple databases, they may not be able to communicate. Like this can communicate with this, but this cannot communicate with it. But still, if someone tries to fetch something, someone gives a request to this, it should get a response. If someone gives a request to this, it should get a response, even if the response is wrong. Like that is the keyword here. The response might be wrong, might be outdated, but still the response should be there. That's what availability is. And the question is, why would somebody want a wrong response? We do not. But sometimes getting a wrong response gives good user experience than getting no response. So it is possible that if you see, sometimes what happens is, if some celebrity is there, okay, there is some celebrity, let's say Tom Cruise. When this guy makes a post, I'm assuming he's very famous on Instagram or Facebook. Whenever this guy makes a post, it is possible that you see 100k likes and your friend sees 102k likes. Why? This is because it does not require strong consistency, but it requires availability. It is possible that there are thousands of nodes which are talking to each other. Some nodes may not have updated each other, so that's why your phone is connecting to different server, your friend's phone is connecting to different server, and that's why you are seeing different numbers. So this is where availability is important, because if it happens, let's say you see 100k and your friend sees nothing, or your friend sees 102k, you see nothing, then it will be a bad user experience for you. You would say that, okay, I'm not going to use Instagram ever because Instagram does not prioritize you. But you don't say that, right? That's because of availability. Even if the data is wrong, it will still show you. And partition tolerance is the system continues to function despite network partitions. The system continues to function despite network partitions. So even if there is a network partition between two nodes, as I told you right now, in this I give the example that the wrong data comes. Okay, but what if somebody requests for this data and there is network partition, means these cannot communicate with each other? What happens? The request has to be diverted to some other node and the response should be there. So this is what C, A and P means according to the definition. Okay, now we say that the CAP theorem states that there can be, actually right now I have only given you the definition of CAP. Now comes the theorem. What is the theorem? Theorem states that in a distributed system, only two out of three guarantees can be achieved simultaneously. Can be achieved simultaneously. Only two out of three. All three cannot be achieved. Either it will be CA, or it will be AP, or it will be CP. Okay, it will never be all three. This is what CAP theorem suggests. But there is one more catch here. This P is unavoidable. Okay, so basically it's not CA or CP or AP. Actually it's always CP or AP, because this is something which is beyond our control. We cannot control P. So we need to decide whether we want CP or AP, whether we want consistency or availability. Because for systems, let's say like Instagram, consistency is not important. So availability is important for them because they want their users to experience availability. But for systems like banks, availability is not important. Availability can be compromised, but consistency cannot. So for them, consistency is important. For Instagram like systems, availability is important. For banks, why consistency is important? Because let's say you have $100 in your bank account and you withdraw $100, then if it is not updated at the moment, let's say it does not get updated, it says that, okay, let me prioritize availability and not consistency, so it will still show 100 and somebody can withdraw 100 again. So when you already have 100, how can you withdraw 200? You cannot, right? So that's why consistency is very important in bank systems. They, if you see, sometimes your bank will show you, okay, the server is not available, or the server is busy, or the request cannot be fulfilled at this time. Why? Because your bank is prioritizing consistency. Okay, and you know that this is something that you can bear at the moment. Okay, so it's always CP or AP. Okay, next, obviously, but in theory we study everything CA, CP and AP. So what are CP systems? So CP systems prioritizes consistency and partition tolerance over availability. So they ensure data uniformity and resilience. Data uniformity and resilience. Resilience, why? Because of P. Even if the partition tolerance happens, network resilience should be there. And uniformity because of C. Consistency means data uniformity. Now, if we have CA systems, then what happens? Again, it prioritizes consistency and availability. Thus, it will potentially sacrifice partition tolerance in theory, obviously. Okay, so it will ensure data uniformity and availability. Okay, and now we have AP systems. It compromises on consistency, but it prioritizes availability and partition tolerance. So it ensures continuous service and resilience. Continuous service and resilience. Okay, so this is what each CP, CA, and AP systems mean. Okay, let's take a real world example. So CP, what kind of databases ensure CP? PostgreSQL. Mostly SQL databases ensure CP. They want consistency because of the transactional guarantees that they have to provide. AP systems are systems like Cassandra or DynamoDB. Okay, and there are no actual practical examples of CA systems, so I don't have any example for that. I may be wrong, but I don't think there is anything which would obviously prioritize CA, because if there is a network failure, if there is no network, you cannot guarantee C or A, right? So if your network itself goes down, then you cannot connect to anything. How will you ensure consistency? Because if there is no network, obviously it is consistent because everybody in the world will see failure or 404. Yes, obviously it is consistent, but yeah, it does not make practical sense, so I'll not talk about it. Okay, also, last few things are, what are the challenges? What are the challenges that come with CAP theorem? The challenges that come up with CAP theorem are, one is balancing trade-offs. Means we need to choose between CAP, because obviously when we look in at hindsight that okay, Instagram obviously has to be an AP system, a bank obviously has to be a CP system, but when we make our new system, it might not be as straightforward as a banking system or a social media network. So we need to choose whether we want to prioritize C or A with P, whether we want our system to be CP system or AP system. Also, another thing is application specific decisions. So decision making should be based on the specific needs and requirements of the application. Okay. So what's the conclusion? The conclusion is that CAP theorem guides the design of distributed systems and influences architectural decisions. So if I have to write it, CAP theorem, wait, before that, let me add a section called conclusion. So CAP theorem guides the system design decisions. Guides system design decisions of distributed systems. And also it helps us in making informed decisions. So informed decision making. If we understand the trade-offs, then it will help us in making informed decisions for the system architecture. So that's it. I hope this clears everything about CAP theorem. So yeah, thank you for watching. Please remember to like, share and subscribe. I will see you in the next one.